understanding. I will cover the topics of GDPR from a technical perspective and try to be both brief, but also go into some details. A short slide about me. As Alishka said, I'm the founder and CEO of Log Sentinel, a secure audit trail logging company. Why I'm qualified to talk about that? I was former IT advisor to the Deputy Prime Minister of Bulgaria, and with that role, I was exposed to both writing and reading legislation and translating technical terms and legal terms in both directions. So this is why GDPR comes in the sort of crossroad between technical and legal. I'm a software engineer by profession, a privacy advocate as well, and you can check my blog for more details. So what is GDPR? It is a common EU law that applies directly to all countries. It has sparked sort of panic, I would say, mostly because of the fines, the huge fines that it prescribes. And there is insufficient understanding on what exactly has to be done in order to get your companies or your systems GDPR compliant. GDPR is also an opportunity where you can really protect your customers' data. You can turn GDPR compliance into a competitive advantage. You can optimize your processes, get your systems more secure, and get the trust of your customers. A short slide about terminology, what the regulators mean by particular words. In the regulation, when you read it, a data subject is practically the user, the person. Personal data is any data that identifies a person or is about an identifiable person. So if there is a data about a person that could be identified based on some characteristics, it is personal data. So practically, it is all data about a user. Data processing is any operation on that data, and the regulation distinguishes controllers and processors. The controllers are the entities that collect the data, or that are actually the owners of the data and that they actually use it. And processors are third parties that just process data on behalf of controllers. These could be cloud service providers or any third-party service. The GDPR has some really nice principles. The lawfulness purpose limitation, you can see these in basically all introductory or even in-depth presentations. Allegedly, that applying all these principles leads to magically having the users protected. Now, how that magic happens, it's not that trivial. When a service or a company processes personal data, when is it allowed to? First, it's based on user consent. If the user has explicitly consented, then it's okay. It could be also for performance of a contract. It could be required by law. It could be the legitimate interest of a controller, which is a very broad term that lawyers have to kind of explain why exactly a certain processing is in the legitimate interest of the controller. It is basically when the user is most likely to assume that their data are processed in a particular way. For example, if you get an address when shipping, then it's obviously that you're collecting the address in order to ship the data, to ship the product. So that's most likely a legitimate interest. Or it could be any combination of the above, because you can be processing data in multiple cases based on different legal principles. I'll go through a few GDPR functionalities that are required in systems, but functionalities are only part of it. I mean, don't assume that a system is compliant or a company is compliant only if it has these features implemented. It's not enough. There are also processes, there are internal documents that have to be updated, etc. The short list of the functionalities are the forget me, the profile restriction, the data export, seeing all the data, consent, age verification, data destruction, and so on. Let's go to forget me. This is the right to be forgotten or the right to erasure. It should basically delete all data relating to a user. That doesn't apply in all cases. I mean, if the user has given their data based on, for example, performance of a contract, you're not obliged to delete their data. So if, for example, you're a bank and there is a loan, obviously the user cannot say, I want you to delete and forget my loan. So the hypotheses in which this applies are limited. In code, it would look like that, to be forget user UUID, for example. It's useful for integration tests. So when you run an integration test, it inserts all kinds of data, and then at the end, you would like to keep the database in the original form. So you just say forget user, and then all of that data gets forgotten, which is very useful for integration tests. The question is, what about foreign keys? Well, there are multiple options depending on the particular use case. You could allow knowable foreign keys and just know them out. You could just anonymize the user data, so the names, the emails, the IP addresses, all of that, and leave the ID and all of the connections, all of the foreign keys to other tables. So the data, in fact, remains there, but is anonymized and unlinkable to the user. There could be a cascade delete. So depending on the tables, you could just cascade a delete of a user table, and then that would chain delete. That is risky, probably not applicable in many cases, but just to have it in mind. Deletion doesn't have to be immediate. You could have a user cleanup job, for example. The user submits their request for deletion, and then that gets queued and gets executed once the job runs. There are complications, of course. In the case of event sourcing, Frans will be talking in much more detail about that, but the keyword here is crypto shredding. What about blockchain? I mean, it's probably still a rarely used technology, but it kind of conflicts with the right to be forgotten because you cannot effectively delete data from the blockchain. So have in mind that if running or experimenting with blockchain, do not put personal data there. You should notify third parties. So if you have pushed personal data to CRMs, to payment gateways, to other systems, you should invoke their APIs and also forget the user there. The right to be forgotten also applies to indexable pages, to pages that search engines index. And for them, you have to return 404, and eventually they will be forgotten from the search engines. What about backups? That is a very tricky part, because what happens if you forget a user, but then you happen to restore from a backup, then the user will be again in your database. So normally you would store the IDs of the forgotten users in a separate location. Could be a separate database, could be even a text file, I guess, in simple cases. And then upon restoring a backup, you should go and forget the users that have been stored in that separate location. And while before there could be an excuse like my data model doesn't allow for it, for forgetting users, it shouldn't be an excuse anymore. I mean, the data model in most cases allow best effort for getting users. There's also the functionality of restricting processing. Now that is similar in terms of the behavior for the end user, like forgetting. It should feature a button in the user profile that says mark me as restricted profile, or restrict processing of my personal data, just as there would be a button forget me. But it could be a database column that's just a Boolean column saying this user has been marked as restricted. And what should happen in that case is that the user shouldn't appear in any searches, they shouldn't be getting emails, they should not exist in the system for practical terms. They could still be in the database, but should be as if they're not there. That the requirement for notifying third-party systems is also true. For example, if you have the emails exported to MailChimp, for example, then you should also mark this email as restricted and not send emails from the third-party system. Again, 404s for public pages. The question is why? Why would a user object to his data being processed or restrict their data processing, but rather than just being erased? Well, they could want to do that for a short period of time. For example, some people want to disable their Facebook profiles for a month and then go back to that. And they wouldn't want all their friends, their pictures gone. So use cases like that. You should also be able to export the user data in a machine readable format. In theory, the idea is to to avoid vendor lock-in. That's in theory. Obviously, if you export all of your Facebook data, for example, I'm not aware of any other social network that could import it all immediately. But in theory, in the long run, that could work. The recommended formats are the standard ones, the JSON, XML, or CSV. My recommendation, it's not to be found anywhere in the official recommendations, but that's a personal one. I would prefer schema.org definitions. That would make it easier for interoperability between systems. Again, exporting your data could be a background process that sends emails when the export is done. Twitter is doing that at the moment. If you say, I want all of my tweets exported, you request that gets put into a queue, and once it's ready, you get an email, you can download your Twitter database here, and that could happen in half a day, for example. All of that, including export data, even including forgetting users, restricting users, etc., could be a manual process. I mean, it doesn't necessarily have to be functionality in code. But being a manual process means each time a request comes, a database administrator or developer goes and manually either exports data, writes some select queries, or goes and deletes a bunch of records. It's an error-prone and tedious task, so I would recommend implementing them in code, these functionalities, rather than leaving them as manual processes. You should export all data about the users, the associated things. For example, if they have sent some messages or made some orders, you, I believe, should also export these. Should you export system logs, like, for example, debugging in info and warn information? Unlikely. I mean, most probably no, and that's because one of the best practices is not to put personal data in these logs at all. You should also export data that you have forwarded to third-party systems. Ideally, they should have APIs for that, so that would not be such a burden. You should have consent functionality, and I accept the terms and conditions and the privacy policy and whatever else doesn't work anymore. The regulation is very strict and explicit that you should ask for consent for each individual process that you have for processing personal data. So these checkboxes should be clear. They should not be pre-checked, and they should correspond to the processes that you have come up with during your data audit. So you should list all your processes that handle personal data, and then you should have checkboxes for all of them that require consent. Some of them won't be based on consent. Some of them will be based on legitimate interest or legal requirements. But for the rest, for the consent ones, you should have checkboxes. Consent should be stored in a more or less secure way. Boolean column may or may not be enough, because regulators have different views. That's one of the issues of the regulation, actually, that there are not necessarily clear answers to everything. And even though it unifies the legal framework for personal data protection, there could still be differences between regulators. There's a procedure for regulators to align their positions, but I'm not sure, at least initially, how that would work out in practice. So you could have the consent stored in a special consents table, or you could store it in an external service, or it could be timestamped with a secure timestamp. Any of these might work. And most importantly, you most likely have to re-request consent for existing users. So if they have clicked, I accept the terms and conditions, that does not follow the current regulation rules. So if consent hasn't been gathered according to current regulation rules, then it should be re-requested, which would mean just sending a bulk of emails to all of the users, asking them, okay, now there's a new regulation. Do you want to confirm your consent for this, and this, with checkboxes again? There's another requirement, and that is for age checks. On registration, you should ask for the age of a child, of the person, or you should ask them to confirm that they're older than 16 years old, which is the limit in the regulation. It is a bit tricky because some countries may impose different limits. So be careful on the legal side there. But how do you implement that is the question. How do you ask for parent consent, which is required by the regulation? Well, currently there isn't a clear way. The regulation says the controller shall make a reasonable effort to verify, etc., taking into consideration available technology. What is that? Well, you could ask for parent's email and then send a link there to get clicked and registered, which obviously the child could just register a fake account, a fake email. You could, strangely and funnily, but still an option, request a selfie with a parent and have it uploaded with the current date on it. Some websites do that at the moment. Not sure if it's a good idea. You can use the EID scheme in your country if such exists. For example, Estonia has it, the Netherlands has it, but Bulgaria doesn't yet, and other countries also are not there yet. But you could identify, you could ask the parent to identify with their state-issued electronic identifier, and that could confirm that they indeed agree. You could also actually make a 0 and 1 cent cost transaction to a credit card, also an option depending on the use case, but careful on how you actually go on to implement that, and it depends on the particular country's regulator recommendations, what is enough to prove a parent agreement. You should limit data retention. You should not store data more than necessary. What does necessary mean? Depends. You could have a database column for data retention deadline, and then have a job that goes and clears that data. It could have a real world event attached to that. So the deadline could be extended if, for example, the good hasn't been delivered. Someone lost it in the mail and you should resend it. Then the deadline for keeping the address, for example, of the user could be extended to until they receive the package. Now some best practices. You should encrypt data as much as possible. This is not a strict requirement of the regulation, but it helps in proving that you have put effort in protecting the user's data. You should encrypt basically anything. Communication, data in transit, data at rest. Again, if it's too much of a burden, for example, to introduce LUKS encryption, then probably don't do it now, but still try to go in that direction in the future. And obviously encrypt your backups, that is a given. You should implement the so-called pseudoremisation. It is practically, it's according to the definition, it should allow for reversing of the pseudonym, so replacing personal data with another view of that data that could not be linked directly without knowing, for example, a secret or encryption key. But you could also use bcrypt or PBKDF to just change it and pseudonymize it forever. That depends. For example, if you use the real production data for staging or tests, that could very well be pseudonymized with bcrypt, because people that have access to staging or tests should not be seeing the real production data. Some databases, like Oracle, for example, do have this functionality built in, but you could also implement it yourself. You should also protect data integrity. That could mean a checksum column per record, could be enforced by the application layer, could be sent to third-party services like the one I'm building. That very much, again, depends on the particular use case and what the regulator prefers. And a few other things. You should have a GDPR register according to Article 30, and it should preferably be not in Excel. Could be a third-party service, a very simple CRUD application, whatever. Just Excel is a bit hard to back up, to be highly available, etc. You should log access to personal data. If a staff backend admin checks the data of some people, it should be audited, because you have to prove to the regulator that only people that should have access have had access. And finally, some bad practices, some things to avoid. Don't log personal data, as I said, just IDs. Don't use data for purposes that the user hasn't agreed with, because you're obviously violate their consent. Don't request unnecessary data. Don't assume third parties are compliant. If you use third-party service, do some effort, ask them, are you compliant? At least get a document or an email saying that, okay, we have done this and this. Don't assume that having ISO whatever makes you compliant. It doesn't. It helps, but doesn't make you fully compliant. And some obvious things like don't dump personal data on public servers or buckets, which sounds obvious, but the latest leak has been exactly that. So try to avoid that. And in conclusion, GDPR would require changes, but mostly they would follow from best practices. They would be useful to customers. If you have followed the previous directive, then most of these best practices and some of the functionalities would be there anyway. The majority of these changes could be implemented within a few sprints. And I think that the spirit of the regulation is that you should be conscious about processing personal data. It's not a one-time effort that you implement some features, write some documents for procedures, and you're done. It should be sort of a culture that every time personal data is concerned, you should be thinking more and thinking twice, how exactly are you processing it, who are you giving it to, how are you protecting it. And with that, I'd like to thank you. And I'd like to give the word to Frans, who will be having a very interesting talk about crypto shredding. So there you go.
Thank you, Bozo, for this great overview and introduction. So like you said, my name is Frans van Buul. I'll zoom into one specific aspect of GDPR compliance related to event sourcing and talk a little bit about the product that AxonIQ has to offer for that particular thing. So first, let's have a look at what event sourcing is. Event sourcing essentially is a specialized form of event-driven architecture. So event-driven architecture is definitely one of the major technology trends of 2018. One of the reasons is that it really plays very nicely with a couple of other trends like analytics, like IoT, like machine learning. So event-driven architecture is actually something really simple. It's an architecture that focuses on events. It's useful to think about what an event is exactly, because sometimes it gets confused with something a lot more generic, like a message, or gets associated with reactive programming or anything like that. An event specifically is a description of something that has happened in the past. It refers to the past. And it has a couple of interesting consequences from a programming perspective. So an event, for instance, can never fail because it already has happened. It can never change. It already has happened. So event-driven architecture is an architecture that uses these properties of events to do all kinds of cool stuff. Well, event sourcing is a form of persistence. So it's a mechanism to store and retrieve data to a persistent form that is based on events. To understand it, it's best to contrast it with more traditional forms of persistence. So what we usually do with computer programming is to store the current state of objects directly into the database. So you get your CRUD operations, or in SQL terms, insert, select, update, delete. With event sourcing, we do something quite different. We say that all state change to an object has to take place through events. There cannot be any state change without a corresponding event. We distribute those events, so other interested parties may respond to them, but also persist these events into an event store. And then if we need to access the current state of an object, we don't have the ability to access that directly because we don't store it, but we can replay those events in order to achieve the same state again. And because of their very nature, these events are immutable and undeletable. So that's event source persistence. To make that a little bit more clear, we have an example here. In an e-commerce system, I could order a meal for the night, like a pizza and a soda. So that would be an order for customer Frans. And in a traditional persistence system, that would look something like this. So the order gets gradually built up, and these items get added to it, and it changes, and this may be its final form. In an event source system, the events that occur when creating this order would all get stored. So it might look something like this. So we create an order. I say who I am. I'm customer Frans. I add a pizza. I add some ice cream, then I add some soda, remove the ice cream, and then actually confirm the order. The net result of the form to the right is exactly the same as to the left. From a delivery point of view, it's the same stuff that needs to be delivered to my doorstep. But you see that to the right, we store a little bit more data. We have captured the fact that I have considered ordering an ice cream, but finally decided not to order that before confirming the order. So we have more data. That data may actually be valuable. So why do this? Because it is an additional complexity, obviously, so there should be a good reason to do that. There are actually many reasons. The main reasons are from a business perspective. I think they fall in two groups. Both are centered around the value of having historical data. That value may present itself in the form of auditing and compliance. That has to do with being able to look back exactly what happened in individual cases. And then there is the value of being able to examine your entire data set. So data mining, analytics. That would happen in the case of the ice cream. If you were the salesperson at that restaurant, you would be really interested to know which customers you could have sold ice cream to and why ultimately you didn't. So there's a lot of value there. In addition, there are a bunch of technical reasons why you might consider event sourcing. In combination with CQRS, it allows you to replay state into new read models, for instance. It's a nice way of capturing intent, many other reasons, but the business reasons usually dominate. Now, how does this relate to GDPR? There's one article in particular that this relates to. It's the right to erasure, Article 17. Bozhidar already mentioned it, which essentially states that a data subject can demand that you erase all data you have on them. That's not an unconditional right. You cannot go to a bank and say, well, forget that, I owe you money. But generally speaking, data subjects can ask that you delete data about them. Now, with event sourcing and GDPR, there's a good and a bad thing. So the good thing is that you keep all history. So if you look at what Bozhidar told us about how to maintain proper track of consent, then event sourcing is ideally suited for that. But that Article 17 mandatory erasure is a challenge, because these events are immutable and undeletable. So if you have personal data stored in those events in your event store, there basically is no obvious way to erase data from them. That's not a normal operation in an event source system. So how to solve that? Let's have a look at some ideas. So one thing you might consider is deleting and modifying events anyhow, because the event store is conceptually append only. Technically speaking, it's probably just files in a database, so you could change those. The problems with that is that it's really difficult to do, because you have to look into the event payloads. You may trigger inconsistencies in your event stream because future events may depend on other ones already having taken place. That makes it expensive. And importantly, if you use event sourcing because you really want to have this reliable, undisputed audit store of what happens, once you start messing with that as a regular operational procedure, the entire credibility of that mechanism is harmed. So it diminishes the value of the event store from that perspective. So while technically maybe possible, this has a lot of drawbacks. Another pseudo solution that we sometimes see is this reinterpretation of the law. There is the notion that in GDPR you wouldn't have to delete data from backups, and that it's only for operational storage. And another notion that we sometimes see is that you can keep data exempt from deletion when it is being actively used in a legal claim. So people, based on these things, people say, well, I don't have to delete data from my event store, I can just delete it from my read models, and then it's fine. That actually doesn't work. So for the first thing, that's just not in the law, period. There's nothing like that that suggests something like that. And the second thing goes against the minimization principle. So there is, in fact, an article in the GDPR that says that you can keep data for legal purposes, but that obviously should be interpreted as referring to data being actively used in a ongoing legal process, and you cannot use that to preemptively say that you can keep all data that you might imagine you would ever use at one point in a legal process. You can generally, with privacy law, you should interpret those entitlements that you have to use data in a minimized way rather than in a maximized way. That's the minimization principle. So we don't believe that these escape routes through reinterpreting the law actually work. And then another suggestion that's being put forward on social media is to use separate contexts. So what you could do is in your entire system say, well, I store my non-personal data in an event-sourced context, and then I store my personal data where I really have to be able to delete stuff in a non-event sourced context, and I bring them together in read model projections and secure rest terms. That introduces a lot of complexity. Kind of depends on your domain. If your domain is in such a way that it naturally segregates those two parts, then it may work. But in most domains, personal data and non-personal data would really be closely related, and this would have a profound impact and a negative impact on your application architecture. So it doesn't really seem like a good general solution for most cases. This is where we are. We saw the GDPR versus event sourcing situation, generally a good thing, bad thing for mandatory erasure, and all these existing ideas have some major downsides. So this situation led us to start thinking about a separate GDPR module for AxonIQ, which is not an overall GDPR compliance thing that will help you with everything. It's a very focused solution to mandatory erasure in an event-sourced system. And the core idea behind the module is cryptographic erasure or crypto trashing, which Bozhidar already mentioned. What you do is you store data in an encrypted form, encrypted using some key. And then if you want to delete the data, you throw away the key. And because the key is no longer there, you cannot access the data anymore. That's the basic idea of cryptographic erasure. Importantly, it's not something that we invented. It's not a novel idea. This is as a data sanitization strategy, so for deleting entire disks, actually a very common thing. It's built into many self-encrypting drives that have this command that you can send to the drive to delete the entire drive. It's also built into big storage arrays where you can have thousands of drives in them. And because it's so widely used, it's also supported by storage security standards, so both an ISO standard and an NIST standard. So this is a totally accepted practice, this cryptographic erasure. What we set out to do is to implement the same idea that's already accepted on the media level to the application level for Java, so that application programmers can start using it as well. Requirements that we had for that, first of all, that it's really easily usable, so no changes to the business logic. And we also wanted, of course, to integrate this with our Axon framework. Want to be as generic as possible, so you can use it with Axon 3 or Axon 2, but also totally without Axon. If you don't use Axon framework, you may still use the GDPR module. It's also independent of serialization and event source choices. So some of our Axon framework users use XML, others use JSON, some store the data in a relational database, others in Mongo, some in AxonDB, and it will work in all these cases. It's not tied to any of those implementations. We wanted fine-grained control, so you can decide exactly what you want encrypted and therefore also what you want erased by deleting a particular key, and that may be all fields in a particular object or just a subset, whatever is needed. And of course, this thing needs to have the highest possible long-term security. You don't want to use a crypto algorithm that can be broken in 5 years, because then you cannot rely on the cryptographic erasure. So how did we implement that? The API that we provide looks like this. There is this field encryptor thing in Java. A field encryptor has methods to encrypt or decrypt an object. What the field encryptor does is entirely driven by annotations on the object's fields. So that's how you configure this. You put annotations in your Java object saying, I want to encrypt this field and I want to use this field as an index for the key. I want the module to look into this collection to see if there's anything to be encrypted there. That's how it works. The field encryptor uses a crypto engine, and the crypto engine is responsible for key management, so creating keys, getting keys, and for getting a cipher instance, so an instance of the algorithm that does the actual encryption. And of course, that's also where you can delete keys. We provide 4 implementations of the crypto engine with the module, but there is of course the possibility to create implementations of your own. The standard implementations can be in memory, that's just for unit testing. We can use a relational database through JPA or JDBC. And then there's even the possibility to use a hardware security module for the maximum key security in rare use cases where you need that. And to integrate this with Axon, what we've done is to create a serializer, so an Axon serializer, which always gets invoked when an event needs to be persisted or sent over the wire. And this field encrypting serializer uses a field encryptor and a delegate serializer, whichever one you choose to use. And when it needs to serialize something, it will first perform encryption and then do serialization using its delegate. And it will apply the reverse procedure, of course, upon deserialization. And the nice thing about this is that if you put the annotations on the objects and then configure that serializer in your Axon setup, that's all you have to do. Point on, all this encryption will take place entirely transparently, and that's why it doesn't affect your business logic at all, and really easy to implement. We don't have time for a full demo, but just to give you a very short impression of what it looks like. Here we have a class, a new customer registered event. It carries a customer ID, which defines which customer this event refers to. So I'm putting the data subject ID annotation on there to tell that to the GDPR module. So it will associate a new random key with that customer ID. And then the field name is personal data, so this will get encrypted. And in this map of addresses, the value side of the map is also personal data, so it will examine those address objects as well for personal data. At this point, we have done presentations like this a couple of times, and a few questions always pop up. So I'm going to address those preemptively. Basically, it's those 4 ones. So first, there's a concern about long-term security, because encryption algorithms secure today may be insecure tomorrow. People ask, is this actually legally allowed under GDPR? There are sometimes some concerns about key management and key security. And people are asking whether this is open source. Well, the answer to the last question is no, but I'll answer all of these questions in more detail. First thing about long-term security, totally depends on the algorithm that you choose. If you would use an asymmetric algorithm like RSA, the key size that you would need to use would very much depend on the time that you need the data to be secure. There would also be very strong concerns about quantum computing attacks against that as well. What we are doing is using AES, industry standard symmetric algorithm. We recommend to use that at the highest key size, 265 bits. This is the same thing that's also being used to encrypt top secret military information, for instance. There is no known attack against that. Just looking at the numbers, it's totally impossible to brute force that. And importantly, it's also totally impossible to brute force that even if you would have an advanced quantum computer as may become available in a couple of decades. This provides very credible long-term security, and this is exactly why it's not just us saying that, but it's also NIST and ISO accepting this type of encryption as a valid implementation of the crypto erasure idea in their standards. So the other point, is this allowed under GDPR? Well, to examine that, first of all, GDPR is very explicitly technology neutral, because technology changes a lot faster than legislation. They don't want to have to adapt the legislation to all new technologies. So you have considerable freedom to choose technological implementations there. And in particular, it doesn't define erasure. Erasure is just that erasure, and you can implement that technically as you would like. So the question is, how strong is a particular erasure technique and how strong is this crypto erasure idea compared to other practices. What we believe is very important is to make a fair comparison and compare it against the reality of other deletion methods and not against some ideal situation where deletion is absolute. If you look at it like that and compare it with the normal SQL delete, then it's important to note that a SQL delete command doesn't actually delete data from disk. It's still there. That's actually a pretty weak form of deletion, which is still perfectly accepted as an implementation of legal deletion. Now, since crypto erasure is at least as strong as this traditional delete, we believe it's a totally valid implementation for the erasure should be legally. So sometimes people ask, well, do you have some kind of certificate or anything like that that validates that this GDPR module erasure is legal erasure? Answer is no, we don't, because such a thing doesn't exist. You don't get it with a database either. You don't get a certificate saying that your SQL delete command or your Windows delete command, your Linux delete command is legally deleting anything. You just have to assess this technically, and then if you do a fair comparison, you will see it's strong enough. Third of the 4 questions, are keys secured? First part of the answer to that is that they are as secure as you want them to be. You can store them in a database, and then you would get your regular database security, your access control, potentially field level encryption in the database. But you can also use a hardware security module, storing the keys on smart cards and do all the encryption on those smart cards, or define any implementation of your own. But very importantly, I think that from a risk analysis point of view, you don't have to worry too much about key security, because these keys are important, but not more important than regular data. And to illustrate that a little bit, if you compare the situation without and with crypto erasure, what's in the database, then without crypto erasure, you would have some clear text event data records, and that's it. You would have many of those, of course. Now with crypto erasure, you would effectively replace them by encrypted versions of those event data records, combined with a key that's needed to decrypt the record. Now, if you look at this from the point of view of an attacker, like what do you need to steal before you get unauthorized access to data? Then, of course, to get unauthorized access to the clear text event, you need to get that event data. And then to, in the crypto erasure case, you need to get access to the event data record and the key. Which means that if you store those keys just in the same database alongside that data, nothing changes from a risk analysis point of view. It's the same effort that an attacker will need to get into to get access to the data, and getting access to the keys in and by themselves doesn't give you access to anything. You still need to have that data. So in normal cryptographic situations where you really do encryption to ensure confidentiality of data, and you have a single key that you use for a large volume of data, then of course keys are golden and it makes sense to use very specific key storage. But for this crypto erasure use case, from a risk analysis point of view, it's fine to store keys in a regular database. But again, if you don't believe that and you have some specific need to store data, store keys in a more secure way, the module supports that as well. And the fourth of the questions, is the GDPR module open source? Well, no. There are a couple of aspects to that. So is it free? People often say free as in beer, like free, no money. It's not like that. It's a commercial closed source offering, and we have very flexible pricing so that we can both provide enterprise-wide licenses to big corporations, but also single project licenses for startups. So if you're interested in obtaining one, just contact us to discuss, and we can provide you a quote. Another aspect of openness is it open as in transparent. And importantly, it is open in that sense of the word. We are 100% transparent about what the module does. So we fully describe the cryptographic scheme that we use. So the cryptographic algorithm is not something that we have invented. We just use standard AES, but then you have to package that into a scheme of a set of operations that you do and binary formats and that kind of stuff. All of that is fully described, and you can hand it over to your security auditors, for instance, for review. And also the scheme is not patented. So what you can do is implement that yourself in another language or have someone else implement it. That's totally a freedom that you have. So in that sense, it is very open. And just to illustrate a small part of that, this is the encryption scheme of how we get from a clear text byte array to an encrypted byte array that we then store in your Java object. I won't go over all the details right now, but importantly, all the facts about how it works are there. Zooming out a little bit, this is the bigger picture of where this module fits in. Like I said, it's not a one-stop solution for all your GDPR needs. It's not even a full solution for all your GDPR erasure needs. It's part of an overall strategy. So if you get this request in for deletion, you would have to see if it's valid, if you want to honor that. If so, you're going to start a deletion process. In that process, you will need to delete from your event store. You will need from read models. You will need to inform third parties, like Bozhidar already mentioned as well. You will need to inform the data subject. Deleting from the read models is something you could do with the GDPR module, but you can also do regular deletes there. So it doesn't make a lot of sense to implement GDPR module there. But deleting from the event store, that's very hard to do without any specific technology. And that's the thing that the GDPR module makes really easy to implement. So it solves this erasure versus immutability problem. So that's what I wanted to share today. You can contact me directly on my email address if you have any other questions. Of course, there will be some room for questions in the webinar as well. Other than that, if you want to learn more about Axon Framework, we have many options for that as well. So I just wanted to list those here as well. Thanks.